Of course, you're going to have different reagents, different products, but the underlying, the idea is going to be the same. If I recall all the reactions up to this point, I can just write in 2 steps. Okay? So in one step, you're going to have the nucleophile, right? So you have a nucleophile there with the negative charge or lower electron, whatever you have. So this is going to go to the carbon, and then you're going to have the negative charge induced on the oxygen, right? So this is going to give you nucleophile bond, and then you have O minus. That's step 1. Just making the generalized statement, right? So what's going to be number 2 then? So for number 2, you're going to have the oxide ion there, O minus, right? Normally you're going to have the proton there. So then what are you going to have? You're going to have the product, right? OH, nucleophile, that's carbon. Right? There's summary of all. Whatever alcohol you have doesn't matter. So 1 degree, 2 degree, 3 degree. So all gonna have the same basic mechanism. 2-step mechanism. Right? So from here, we're gonna go with a different nucleophile. So first we're gonna see the oxygen containing nucleophile. Of course, one's going to be water, very simple, and then going to be alcohol after that. And after that, we're going to see the nitrogen containing nucleophile. Okay? So amine, for example, ammonia. So these all are nucleophile. We're going to see these reactions again. For these reactions also, you're going to have the same basic 2 steps. Okay? Doesn't matter what nucleophile you have, nucleophile always going to go to the carbon center. Right? And the proton or electrophile, whatever you have, they're going to go to the oxygen center. Okay? So are you all clear on these 3 steps? Because we're going to see this again and again. So don't be confused with the different nucleophile you have. The principle is going to be the same. Let me know if you have any confusion on these 3 steps. All clear? Okay. Nucleophile to the carbonyl carbon. Electrophile to the carbonyl oxygen. Okay? Remember these 3 steps. So I'm going to point this again and again for the next upcoming reactions. Okay? Now let's see. One going to be the cyanide. So in cyanide, what going to be the nucleophile? So you're going to get Cn minus S plus, right? Now you know where to connect. You have to do the same thing. Cyanide going to go to the carbonyl carbon. S plus going to go to the carbon dioxide. Right? Then what going to be the product? So you can have OH there, Cn, and then what will go behind that? Right? So this is called the cyanohydrine. Right? So here's the one. This is cyanohydrine. So this is going to be the product. If you have the cyanide nucleophile. Sodium cyanide, for example, that's the salt, right? So HCN is a weak electrophile. So metal containing CN is going to be strong. It's going to ionize pretty quickly. It's going to have the strong. Right? Is it different than the previous carbon containing nucleophile? Like organolithium, organometallic compound. It's not, right? Same thing. So Cn to the carbon, H to the hydrogen, right? Now with that, let's see. Oh, we have one example. And then we're going to go to the oxygen. So this is the reaction you have. You know the product. You have the reagent there, cyanide. So what's going to be the reactant? You're going to go back what, right? So let's see. If you have C double bond O, carbonyl compound, right? If you have Cn there, what do you do? You're going to put that over here, and then you're going to write CO minus Cn, right? And then you're going to have the hydrogen after that. So this is going to go over there, and then this is going to be the product, right? So here, this is given. And then Cn is given, of course, if you're fine, right? So you're going to judge this. Right? So you can judge from the product. So the only change you have over here, if you compare with the previous reactant, what is the change? So change is going to be over here, right? That is this one. 2 bond with carbon is not changed. There's the carbon there, whatever substitute you have there, will be as is. So the green circle is going to be the change, right? You do the same thing. So this is going to be the change you have there. You're going to keep everything else as is, right? And then what are you going to do? You're going to make the double bond over here with the oxygen, right? So take the hydrogen out from there, take the Cn out from there, and then make the carbon-oxygen double bond. That's how you do it, right? If you go back. So then you're going to do this, and then you're going to do double bond there, and then you have the 2 bonds over there. Right? That's what you're going to do. That's the reaction. What about for the second one? Same thing. So you're going to do change on that. So put it out from here, take the hydrogen out from there, take Cn out from there. That's the reactant you have. Right? Going backward from the product. Any question on that? No, right? So now we're going to do, so actually we have one more reaction before the oxygen. Okay, we have one more reaction here. The Wittig reaction. Of course, for this also, you're going to have the carbonyl reactions, like for the other reactions, right? So what is the reactant? This one is reactant you have. Right? This is a carbonyl compound. That's the main reactant. And then the Wittig reaction comes from the reagent. So you can also call Wittig reagent. So from this name. So this is the reagent for that. Phosphorus light. So this is the reagent. So you can call this over here. So you have the phosphorus. So pH is the benzene ring. This is not normal pH for acid and base reaction. So pH is going to be equivalent to 1 ring. So for one whole ring like that. So this is pH. Canyl ring. This is the short code notation for the whole ring. So you have pH 3 means you have 3 of these rings there. Alright? So you're going to draw thingy, you're gonna draw like that. So phosphorus, you're gonna have one ring over here, like that. And then you're gonna have another ring over here, like that. And then you're gonna have another ring over here, like that. And then you're gonna have double bond with that. And then you have the carbon there, of course, right? And then you have hydrogen, you have hydrogen. So this is called the phosphorus halide, right? So this name is for the same molecule. That's a short configuration of that. Okay, let's do it. So now, you're going to do the same thing like before. So don't be confused if you see large number or reagent, right? So here, which is more electronegative? Phosphorus or carbon? So you have minus there, plus there. Okay? You can say similar to the organometallic compound. You have the carbon minus there, metal plus, right? Similar thing. So then what are you going to do? In the first step, you're going to do exactly same thing as you did before. Right? So you have the carbon minus. What are you going to do? You're going to connect that carbon minus to the positive center of the carbonyl compound, which is carbonyl carbon, right? As always. So you're going to connect this over here, and then you're going to move the electron to the oxygen, right? So this step is same as the previous one. Remember? Same as this one, and then same as this one, right? So you have the negative nucleophile there, you add it to carbon. You are doing the same thing, exact same thing. So you have the negative carbon, you can add that to the carbonyl carbon. Okay? So now the second step is going to be a little bit different than the previous one, because you have the bulky group there. So the phosphorus is going to make the bond with the oxygen after that, and then you're going to take the oxygen out instead of returning there. So you're going to have the alkene formation, right? So these two are going to stay there. Now let me try to do a different color. So you're going to connect red box with the red box. So you have the molecule there. Alkene. This is a little bit different than the usual product you're going to have. Normally you're going to have the OH there for the carbonyl compound, right? So this is the only one that is slightly different. Have the alkene. Okay? So you're going to see the second step. This is what you're going to do. So you're going to have the PO bond, and then you're going to take out that. So you're going to have the double bond, alkene. Right? If you react the phosphorus halide with the carbonyl compound, what's going to be the product? Alkene is going to be the product. Right? So what you do, you're going to just break this half, and then you're going to break the double bond, and you're going to connect the carbon to this carbon. That's going to be the product. Right? So oxygen out, and the phosphorus part out. So you're going to take this part, half part out from there, and then the oxygen half going to be out from there. So you're going to have the remaining there. Right? Double bond. Okay. That is Wheaton reaction. So this is one of the frequently asked questions. So what you're gonna have is, let me see, yeah, something like that. You're gonna have the questions like this. So carbonyl, right? So you have the carbonyl molecule. So this is the chapter, carbonyl, right? And then this is the reagent you have. This is reagent. We call phosphorus light for that, right? And then you're going to guess the product. So what is going to be the product? Right? So how you make the product? You're going to take this portion of the carbonyl compound without the oxygen. And then you're going to take the carbon portion of the reagent. And then you're going to connect these two. Right? So connect the carbon portion of the reagent with the carbon portion of the carbonyl compound. That's the double bond. Right? So you're going to connect this, right? So this is one half, this is the other half. So that's the half. Right? This is just like connecting two blocks together, right? So what is going to be the other one? This one. So you're going to do the same thing. So you're going to take this half over here, and then you're going to take this one over here, and you're going to connect these two. No, actually, this one is, there is typo over here. So this part is going to be, if you do this, so this is not the part of that. Let me try. So you're going to have that, this, and then double bond, oxygen, hydrogen, that, and then this one, right? And you're going to add that to this part. So what are you going to do? You're going to take oxygen out from there, right? Take the oxygen out from there. And then you're going to put the carbon there. So you're going to put this carbon, right? So I'm going to do this and this. So let me write the part. So you have this part, and then you have this part, right? This one and this one. That's very funny. You're going to have any substitution. You're going to use this one for this product. You're going to have this part can be carbonyl from the carbonyl, right? And then for the light, can be from this part. You can have another reagent, right? So this is the part. Okay? Good? So now we're going to see the oxygen containing nucleophile and the nitrogen containing. So we're going to see different examples. So the first one to start with is water. So this is water, right? So this is oxygen containing nucleophile. So now you know why it is nucleophile. You have these four dots over here, right? That's the reason why. Lone pair of electrons. So now, without looking at the mechanism at all, what do you think the product going to be? So I can guess. So for water, what I'm going to do is I'm going to take the H plus part and OH minus part. So if you apply the same two steps we see before, what are you going to do? So for the carbonyl, so what you're going to do is you're going to add OH on the carbon, and then you're going to put the minus on the oxygen. Then you're going to add H plus on that. So this is gonna be OH, OH, and then you have to run that. This side is the product. With the same mechanism. Remember, I'm not doing anything new over here. Same two steps. So the minus goes to carbonyl carbon, plus goes to carbonyl oxygen, right? Same two steps. So this is called the hydrate. That's the name for that. So hydrate. If you further oxidize that with the oxidizing agent, like this, you're going to give the acid, carboxylic acid. You're going to remove the one hydrogen there, you're going to have the acid, but without any oxidation, this is going to be the product, hydrate. Right, so 2 OH on the carbon. 1 OH from the water, and the other one, it has oxygen from the beginning, right, carbonyl carbon. So you're going to have the 2 OH hydrate. Right? Is this new?
Nope.
No, I should not take this. Very hard. Just remember 2 steps. I showed you before, right? Those 2 steps. Like that. So always you're going to have this one. Right? Same steps. So for O, S and OS, S plus OS minus. So what is nucleophile? So this is nucleophile, right? And then S plus is S plus, so electrophile. So that's the part. Of course, which one gonna be first? That's the question. So you can go in detail on the mechanism. It is not strong nucleophile, so you need catalyst for that. Okay, that's the different things, but product gonna be the same. It doesn't change the product. So if you want to identify the product from the reactant, it doesn't say anything, right? All right. So let's see. So that's why we're going to say the acid catalyzed or the base catalyzed. You can do both, right? So you need catalyst because you will not have the enough nucleophile at the beginning. Because water dissociates poorly, right? What is the dissociation constant? So from lithium you have the dissociation constant of water, 10 to the power minus 14, something like that, right? Very less. So you can have a few ions, that's why you need catalyst, okay? So catalyst is acid, that's plus ion, or you can say H3O plus, same thing. So this is going to initiate the reaction. That's the role of the catalyst. Okay? So before water goes to the carbonyl carbon, this is going to initiate H plus or the proton or Ac, you can call that. So Ac is going to initiate the reaction. So you're going to have the OH on the oxygen. So now you're going to have the carbon plus there. So now it's going to be easy for OH to go, and then you're going to have the OH there. Right? Same product, right? There is no different product. Product going to be the same, but which one goes first? OH goes first, or the H plus goes first? That's the difference. If you have the strong nucleophile, you're going to go first. If you have the weak nucleophile, it's going to go second. So water is weak nucleophile. So OH goes second. H plus goes first. Okay? So if you compare the energy profile, so this is going to be without catalyst, other going to be with catalyst. So Obviously, catalyst is going to lower the barrier, so it's going to be easy to make a product, right? You can see over here. Uncatalyzed is going to have the higher barrier, so it's going to cost more energy to crush that. Okay. Now, base catalyzed. So before you had H plus there, right? So now you have OH minus there. So this is going to initiate the reaction. So now it is strong nucleophile. So this is going to go fast. And then H plus from water, remember? So this is going to go second after that. And then it's going to be released. Remember, you have OH from the catalyst. You need to give back to that. So base is catalyst. So the OH minus from water is going to be free to compensate the base OH there. So again, the product is same, right? We have these two OH there. That's the hydrate. Right? Yes. Okay, so remember NaOH, HCl, H2SO4, HNO3. So these are the strong base or acid. Right? NaOH is strong base. Ammonium hydroxide is weak base. Right? So, in general, you can combine all in one group. You can call that strong electrolyte. So the compound which is easily dissociated to produce more ions, these are strong electrolytes. Right? What that means is NaOH going to dissociate easily to produce ions, Na plus OH minus. Right? So this OH minus is going to be far more than the OH ion given by water. Water is weak electrolyte. So you're going to have few from water, but it will not be enough to react. So that's why it's going to start reacting. So this OH is going to be added to the carbon, and then whatever it is used, that is going to be compensated by the water molecule by ionizing later. That's why it is catalyst. So whatever mole of OH from NaOH is consumed, that mole is going to be replaced by OH of water. That's why it is catalyst. That's it. Right? Good? So now, alcohol. Again, this is going to be similar to H2O or water. Okay? So don't be confused if you see different heading, different reactions named there. The product is going to be formed by the same exact way. So now, when you say the alcohol, what's going to be the formula? ROH. Right? So the alcohol is a derivative of water. That means it's going to have this similar structure than that of water, right? So you can take this part and this part as same. Nucleophilic part, you can call that. And then you have the hydrogen, the plus part later, right? Or you can write this way. RO minus H plus. Remember, you're going to have the pure ionization like water. I'm not saying that this is strong electrolyte, but you're going to have two parts there. One nucleophilic part, which is RO minus, and the other H plus part. Right? So now, whenever you make the product, you're going to do the exact same thing. right? Remember, for the water, let's say you have this carbonyl compound, okay, this one. What do you do? You're going to put this OH over here, and then you're going to put the hydrogen on the other side, right? You did that. So, you did OH and OH, like that. So you do the same thing. So now, what I do is, from there, so I'm going to put OH, OR, and then carbon. Right? So I have the OR part over here, and then I have the hydrogen to the carbonyl oxygen. So I have OH there. Right? So in terms of mechanism, there is no difference at all if you compare to water. Of course, you're going to have different name for the product because you have R there, but the way you're going to make the product is same, exactly same. Right? So you have the OR. So this is OR, right? R is alkyl, and then you have the OH. Right? So this is the product. So the name for that is this. Hemiacetal. That's the name for this compound. So if you have the OR, ethyl group there, that's the acetal. OH is going to take the hemi. So that's the name we're going to call that. Hemiacetal. Both OH and OR are the same carbon as the hemiacetal. Right? It is different than the water as a nucleophile. No, right? So alcohol and water both going to react the same way, like the usual other Grignard or the metallic compound way to the compound, right? So minus part to the carbonyl carbon, plus part to the carbonyl oxygen. Same thing, remember, two things. Okay. So if you see the mechanism, going to be the same thing, right? So what are you going to do? So normally you're going to do the acid catalyst like before. So you're going to have the proton to the oxygen, and then you're going to have the plus charge of the carbon there, and then you're going to have the negative charge bonded to that, to the oxygen, and you're going to have the crown. Right? So why? You have the H going to the oxygen first, because this is also a weak nucleophile. Right? It is not a strong nucleophile like Grignard reagent. Weak nucleophile, so the oxygen center is going to be the initiation center. Right? If you have the cyclic, yeah, you can have that the same way, right? If you have more OH there, you can have also that. So it is hemiacetal, OH, OR in a cycle. You can write that too. So now, one step further than that, you can have acetone. Okay? So what that means is, if you have more alcohol or more concentrated, if you have less water, if you have that, you're going to have the extra step there. That's the extra to give this, which is acetone. So if you don't have enough alcohol there, you're going to stop over here. Okay? So stop there. If more water or dilute or less alcohol you have, hemiacetal going to be the product. Okay? If you have more alcohol to react that, then it's gonna go that. So this is more alcohol. If more alcohol, you're gonna go further. If you don't have that, you're gonna start at MIS. Good. This should be exhausting something. Alright. So now I'm going to see the mechanism. Again, this can be similar to the previous mechanism, right? So what are you going to do? So again, electrophile addition is going to be the first step. So because this is weak nucleophile, right? So oxygen center of the carbonyl carbon will start there, and then you can have the plus and the carbonyl carbon. After that, the nucleophile goes there. So you have the nucleophile OR there. That. And then if you have more water, then you stop over here. Right? If you have more alcohol, then I repeat the same thing. Repeat the same process, another alcohol added there, and then you're going to have the acid. Right? So the second half and first half. Second half going to be another alcohol added there to have this. This is going to be the mechanism. Right? If you see the condensed picture of this, they're the same as before. Right? So simply, to make this easier, very easy to remember, this is alcohol, right? So add that to the carbonyl carbon. Add hydrogen to the carbonyl oxygen. That's the hemiacetal. You have that. Right? And then after that, for the acetal, just add OH, say OR for that. Another OR in place of OH. Right? That's going to be the acetal. So if you remember 3 steps, you can identify the product in any alcohol reaction. Good? Let me know if you have any questions in future. I know if you see different name over here, that will be confusing, more confusing, right? That's why I said, just remember these 2 points. For all reactions, this is going to be more or less common. Okay, so you're going to be small quick on that, based on whether it's strong or weak. So very few quick, but this is the backbone. So you're going to do this for all types of nucleophile. So we are not doing any different than that. Okay, so now we're going to see the nitrogen containing nucleophile. So here again, these 2 are the backbone. And then we're going to tweak after that 1 or 2 steps. So we have a little bit modified product from there. But the starting point is same. There's no difference, right? So whenever you say the nitrogen nucleophile, so the parent of that is this, ammonia. Right? So you can have the derivative of that, which is called amine. Right? So if you have an R on that, R and H2, you can have that. You can have R2 and H there. This is also nucleophile, right? You can replace hydrogen by alkyl group. That's the amine. Right? So 1 degree amine, 2 degree amine, 3 degree amine, based on how many carbon nitrogen bond you have there, but all are amine. Okay? So let's say this one. This is one amine, right? So for ammonia, you replace one hydrogen with this. So let me write this. So you have the hydrogen there before, you replace by ethyl group, right? CH3, CH2. So this is ethylamine. That's the name of that. But this is amine. Okay? So now what do you do? So basically, you're going to do the same thing like before, right? So let me recall two steps, right? So for this amine, how we can write is like this. So you have the nitrogen. Let me write just R for the chain you have there. And then you have two hydrogens there, right? So one hydrogen there, one hydrogen there. Okay? So now, if you break this down, obviously the negative center is going to be the nitrogen. And then you're going to have the positive center there. So this is a light nucleophile, NU, and then this is like proton, of course. You have two parts there, right? So now how are you going to add these? Same two steps. So the nucleophile is going to be go added to carbon. Proton is going to be added to oxygen. So now you're going to add that. So let me add this. Just the normal common. Okay, so any carbon compound there. So I'm going to add this nitrogen over here, and then I'm going to add the hydrogen to the oxygen like before. So now I'm going to do this. So this is N. I have only one hydrogen now. I have R there. And O, and then I have hydrogen there. That's the carbon, right? Just based on the same two common steps we have before. Now we have the same thing here. It's not different. If you compare this and this one, do you see any difference there? Nothing different. You have different R, of course. You have the ring there for the carbonyl compound, right? You have different R for the amine there. But the backbone, the basic idea is the same. You have the OH and you have the CN for the carbonyl carbon. Right? So this is going to be the compound. So this is the initial product. Of course, you're going to go further from there with the other product, but this is the normal nitrogen containing nucleophile addition to the carbonyl compound. Right? So if you go further, it's going to be super confusing if you don't know this. Right? If you have any question over here. Remember always two basic steps. Right? So the nitrogen is the nucleophilic center. You're going to add that always to the carbonyl carbon. Right? And whatever electrophile you have, will go to the oxygen of the carbonyl. Right? So now, for that, let's see. So now, oh, by the way, so what is the name of this? If you name this compound. You have two functional groups there, right? So one is alcohol, another is amine. So which is going to have the first priority? So alcohol is slightly above, amine is to the table. So we're going to call amino alcohol. Okay? So this is called the amino acid if you have the COOH group there, you're going to call the amino acid. It's alcohol, amino alcohol. Okay? So now, let's see. Just the ammonia, without any R there. So what do you do? You're going to add nitrogen to the carbon like before, right? So you're going to have the two hydrogen there. So you have the CN double bond. So this is going to be one step further from the previous product. So initially what do? You're going to add that to the carbonyl carbon, right? So first you're going to do this. And the hydrogen there. So you're going to have hydrogen, and then you're going to have OH, and then you're going to have NH2. So this is going to be the expected product like before in two-step mechanism. And from there, so water is going to be out from there, and then you're going to have the CN double bond there, which is this. Okay? So this is called imine double bond, carbon nitrogen double bond. So this is called the imine formation. Okay, remember you have the compound over here like this one, right? And then you're going to have the water out from there, and you're going to have the further imine. So one step further. The initial product is same as usual. Perfect. Okay, that's the one we're talking about. Right? Good. If you see directly this product will be confusing, so go step by step. First make the usual product in 2 steps, and then go 1 step further from there, you're going to have it. That's easier to just do that. So this is the acidic condition, and then this is the neutral condition you have. Okay? So what you're going to have in the neutral condition, slightly different. Then this is going to be the same as before. That's it. So from there, you're going to go further. So this is same as before. So you're going to have the equilibrium. Okay? So that's the point over here. You're going to have the same product, but you're going to have the equilibrium between the iminium ion. So that's the name for that. Remember, you have the ammonium ion, like that. If you have 4 bonds on that, this is ammonium ion. Right? If you have the all single bond there, it is ammonium. Here also you have the 4 bonds there, 4 bonds, or you have the double bond. Okay? So that's why it is iminium ion, because of the double bond. It is analogous to ammonium ion. You have the pi bond. So here you have no pi bond. Here you have the pi bond. That's the difference. Good? Confused? I know you are confused. Let's see what's this. Alright, so review up to this point, and then ask me, I'm going to clarify. Okay? So always start from the first basic two steps, and then go from there.